Welcome and thank you for joining us today for Your NetOps Tools Are Aging Faster Than Your Network, 5 Emerging Trends That Are Reshaping Network Observability. My name is Raleigh Gould and I'll be moderating today's event. Our featured speakers are Shamus McGillicuddy, VP of Research covering Network Infrastructure and Operations at EMA, and Brandon Hale, CTO at IBM SevOne. Shamus has nearly 2 decades of experience in the IT industry. His research focuses on all aspects of managing enterprise networks, including network automation, AI ops-driven network operations, multi-cloud networking, and WAN transformation. In his role as CTO at IBM SevOne, Brandon shapes the technology, strategy, and architecture behind one of the leading enterprise network performance monitoring platforms. He is passionate about helping organizations ensure robust, predictable performance across their evolving network and infrastructure landscapes. And before I hand things over to today's featured speakers, I wanted to know that Shamus and Brandon will be concluding today's presentation by taking your questions. Feel free to log them anytime by using your Q&A functionality. Also, today's event is being recorded and you will receive a follow-up email from EMA that will include the on-demand playback, a PDF of the slides, and additional information on IBM SevOne. So I hope you will check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, Shamus McGillicuddy. Shamus?
Thank you, Raleigh, and thank you everyone for joining us today. As Raleigh mentioned, we're going to talk about how your NetOps tools, specifically network observability tools, might be aging faster than your network. And we'll be doing that, we'll be framing that within the context of a conversation about the 5 trends that this slide references. So Brandon and I will sort of have a little back and forth about it. It's very research driven because I survey thousands of IT professionals a year, many thousands of IT professionals a year about their networking tool strategies, like the tools they use to design, build, and manage their networks in the enterprise world. So a lot of these trends are kind of shaped by what I've been seeing in my research over the last couple of years. And the trends here in the form of an agenda are application awareness being essential for today's NetOps teams. Maybe you already agree with that. We're just going to provide a little bit of context around the implications of it. Cloud-based management being mainstream now. You are maybe thinking of shifting from having an on-prem self-managed tool for monitoring and managing your network to consuming it as a service, for instance. Software-defined wide area networking, secure access service edge, and multi-cloud are adding complexity to your networks, driving a need for end-to-end visibility. AI-driven tools are streamlining and optimizing NetOps, and there's a big opportunity there for you if you have the right vendors in place who are investing there, or if you have internal tools you're developing maybe. And then AI traffic drives new network observability requirements. We did some research this year where we were looking at organizations that are already in the middle of or having completed some preparation of their networks for AI workloads, AI traffic, and we asked them about how it impacted them from a tooling perspective. So first off, application awareness is essential for today's NetOps teams, I would argue, at least those that are taking a service-based approach to operations. As this director of infrastructure at a Fortune 500 financial services company at the bottom of the slide is quoted. He says, "I don't manage the network. I manage the applications that run on it. You can't start with the network and build your way up to the application. Networks are unstable by nature. If something is broken and not affecting anything, it's not important." So what he's saying here is, like, when he gets alerts, he wants those alerts tied to services or applications, so he knows whether they need to be prioritized or can sit in the queue, for instance. So, and the reason for that is NetOps teams are increasingly resource constrained. Like in our research, 2 in 5 enterprise IT stakeholders cited gaps in skilled personnel as a critical NetOps challenge. And it comes up in conversations that I have with network engineers that like when there's a lot of attrition. When a seat goes empty on their team, management wants to hold the line and say, we're not hiring someone else because hiring someone else is time consuming, expensive, difficult to find the right person. And aren't you doing more automation these days? Like, can't you just get by without? Um, and at the same time, performance expectations are elevating on the network. Like, I just did some research last month that found that, for instance, increased expectations for performance is driving Wi-Fi 7 adoption right now. And then day-to-day operations need to align with business priorities. Like as this director of infrastructure at the bottom is kind of alluding to, I want to manage what's important to the business. I don't want to manage what's important to like the alerts coming out of my tool and like try to, keep everything green because that's never going to happen. Which means that application awareness sort of can guide how you manage and operate your network in a more efficient way. And 1 in 4 NetOps teams actually say that application performance is a critical measure of their success. It's not downtime anymore or uptime. It's not necessarily uptime based SLAs. It's application performance and how you can translate that to experience. Brandon, what do you think?
I really love the quote that you pulled here, and I really empathize with this person, director of infrastructure, because it's such a hard job. And Shamus has done a good job of explaining how it's only gotten harder. He's trying to do more with less people. He's trying to do more potentially with a smaller budget. And I think this quote almost works in both ways, or it really does, because people say, hey, there's no point of having the network without the application. But conversely, I challenge people who say the network's boring, the network's a commodity, the network isn't the focus of the business. You got to ask yourself, how can you deliver applications without a network? Right? Like we need 5G, we need wireless and the transition to 7. We need SD-WAN and SASE. All the things we're talking about is how those branches get to the applications. And so this person's job is really critical. And I really like their insight into I'm being measured by how my users experience applications and the responsiveness that they get. And I'm not necessarily measured by network uptime because that is considered routine, that's considered a baseline, but people are really noticing when Zoom is slow or I can't get to Office and things like that is what's top of mind for his users, right?
Yeah. I mean, I think like 10, 15 years ago, it was a different story. I mean, a lot of network observability tools didn't have much to offer around application awareness, maybe 15 years ago. But now I think most of them do. Like at this point, like I'd say I haven't seen one lately that doesn't have something to offer.
Yeah,
Um, and and it's because customers are demanding it,
yeah.
and because uptime is primitive at this point in terms of measuring operational results, I think.
Yeah, I think this is only sped up. It's certainly not stopping. And this move from applications that people either run locally on their desktop or applications that are built and hosted inside the company's own data center are being largely replaced by AI agents, applications built cloud native in AWS, Azure, etc. Or things that are a SaaS application, right? So I used to run PowerPoint on my local machine. Today, I'm running Office and PowerPoint on Microsoft's machine and Salesforce, Box. All those things are as critical as they've ever been, but they're delivered over the internet. So this person, or people in this position, right? Like many people on this call today, likely in this Fortune 500 running the infrastructure space are not only expected to manage their own network, but they're being asked questions about application performance that traverse the internet and other people's networks. And we're really also trying to consider how can we make application aware network performance also aware of and sensitive to the fact that a lot of your applications no longer run in your own network, but rather run on the internet.
Yeah. think we'll touch on that a bit in a moment too, actually. So second trend that might be aging out your tools is more of like a consumption model type of question.
Yeah.
Cloud-based management. It's pretty mainstream now. Most NetOps teams at this point prefer it as a consumption model of their tools. This network engineering director at a large insurance company who I talked to about just his overall tooling strategy. He said tools have to be deployable in the cloud, either as SaaS or through infrastructure as a service, meaning I will self-manage it in AWS or whatever. We want to ship those
Yeah.
tools off-site one way or another, because I'm sick of paying, being billed by my internal organization for server time. I'm sick of having to maintain a Windows machine or a Linux box or whatever, or VM, whatever for the tool, whatever.
Yeah.
A variety of reasons, really. As you see on the left, drivers of adoption. It's actually these are the ones that they cited the most: the data retention and scalability, and simplicity. Like, all right, so I'm gonna go with a vendor that like can just retain all the data, retain data for like a couple years without having to worry about provisioning more storage or whatever. Which can be an admin overhead issue, like the thing I cited at the top. Ease of use, this perception probably driven by tools like Meraki, which is perceived as like, oh, we're no longer working in CLI. It's all GUI, and it's all simple. I don't know if I believe that is a true truism at this point, just because like for instance, like Meraki, as Cisco starts adding management of all their other like Catalyst switches and so forth,
Mhm.
routers onto Meraki, they've had to add like a CLI tool to Meraki
Yeah.
so that people can interact with stuff at that level when they need to. And then you see on-demand scaling, like, oh, I need to monitor more stuff, and I don't need to, deal with like provisioning more resources or updating my overall deployment of the tool if I outgrow my original deployment. Um, Integration with third-party tools is this perception that like SaaS tool providers offer really good plugins for like east-west integration, north-south integration with other IT operations management tools. And then resiliency, like the tool's not going to go down because they're offering an SLA like 5 nines availability, whatever. Not all, actually, a lot of them don't. But there is this
Yeah.
perception that if it's a true like multi-tenant cloud native SaaS solution, it's going to be more resilient than a monolithic tool. So on the right, you see network infrastructure vendors are increasingly offering cloud-based management, and NetOps teams
Mhm.
um, need to start thinking about how this this can benefit them in the future. What do you think, Brandon?
Yeah, the cloud controllers is something I want to come back to, but the stuff on the left resonates with me. And I think some of these are table stakes for anybody, any vendor trying to offer these folks a robust solution for network observability as a SaaS, right? Like it should have resiliency, it should be on-demand scaling and scalability, right? Like I think everybody will need to do that. Where we're measuring ourselves and trying to be a leader is in the ease of use. We think that we have an amazing design team inside of IBM, and we're really looking at every click to from like the buyer's first experience with the product to getting set up and discovering all the elements of their network to starting to build out reports and alert policies, etc. We're spending a ton of time on ease of use so that we can have people coming into the product for the first time and discovering valuable solutions within minutes, where it used to be not as much of a challenge. If I was going to change tools every couple of years, I might be willing to spend weeks or months getting things set up, but you don't have the appetite in this market, right? Like if you're going to try some different SaaS vendors, it's going to have to be quick and it's going to have to be easy to get you to the point of view where you're to the place where you're able to solve real problems and see the value. So that's an area where we're optimizing. And of course, we think all the other stuff that's mentioned is table stakes, and it's gotta work.
Yeah, and on the right, I was just referencing that one 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 dynamic here is that as you see cloud-based management go mainstream, Meraki, all the other network infrastructure vendors at this point have started offering cloud-based management tools, which actually is
Yeah,
something you need to think about for your network observability tool set because whether it's SevOne or something else, like those tools need to collect telemetry, performance fault data, whatever, from these cloud managed infrastructure uh,
yeah,
solutions, which often changes up how data collection is done because, for instance, like you may not have the option to collect data directly from devices. You're going to have to go through some sort of webhook or API with the cloud controller itself, whether it's Meraki or something else. And I have, as you look from vendor to vendor in those cloud managed infrastructure places, those cloud managed offerings from the infrastructure vendors, like they can vary in terms of like how well you can pull data out of them, how the formatting matches up with what the tools you use for monitoring are capable
yeah,
of working with. And so there will be some turbulence there, I think, and also like vendors like go based on user demand or customer demand from okay, well Meraki is where most of our customers are, we're going to add support for that, and then we're getting some demand for like Arista's offering in this space or Extreme, and so it can unfold over time.
yeah. I want to riff on this a little bit because we're adding support for Meraki and Mist as they develop new stuff, and we also have to keep abreast of kind of all the vendors in this space. And Shamus is pointing out they often have their own controller with their own observability built in. We think for the customers that we work with, that's rarely enough, right? Like you rarely have a single vendor and all of your WAN is set up with just Meraki, or all of your WAN is set up with Mist, right? Like you often have different technologies that you bought in different cycles, and you have to be able to observe all of them and continue to deliver great application performance regardless of whatever kind of edge device is at that branch. And we think that it's really too complex for people to go chase multiple vendors' controllers for information. It's really all best brought into observability suite like SevOne, to say, hey, we can see it all in one place and treat it consistently, regardless of who the vendor or what their controller does. Just normalize it for you.
Yeah, and that kind of leads me to the next slide. As I mentioned, like SD-WAN, SASE, multi-cloud adds complexity, also drives a need for end-to-end visibility. You don't want to, for one thing, you don't want to go to your SD-WAN vendor for insight, and then your switching element management tool for insight, and then your AWS CloudWatch for insight, and stitch all that together into a end-to-end view. Like it's not efficient, and you're gonna find that you're missing things between
Yeah.
between them. So these two pie charts kind of get at the issue that I'm talking about here. On the left, you see how important is it for your network observability tools to be able to monitor and troubleshoot unmanaged networks for which you have little or no administrative control, such as the internet, home office, public cloud. Those are like potential blind
Yeah.
spots to your network observability. And you see um, 59%, more than 59% say very important. Like it's only 2% even deigned to say, nah, this doesn't matter to us. It's everybody pretty much
Yeah.
sees the value of that. And then on the right, how important is it for your network observability tools to provide visibility and insights end to end across different domains, such as switching, Wi-Fi, data center, WAN, network security, cloud. And there, the importance is even bigger. 71% are saying very important. less than 0.5% selected somewhat
Yeah.
unfortunately. They want
Yeah.
end-to-end insights, which Brandon, you were just alluding to around the discussion of the previous slide.
Yeah, back to that first person who gave you the quote about like I'm a director and it's my responsibility to deliver application performance. 10, 15 years ago, that might meant everything within their network under their control, right? Now the entire world is kind of brought into this. Is the application hosted in Amazon? Is it something that I have an express route or like some kind of VPN connection from data center to cloud? Do I have a hybrid situation on the application side? And then as it goes to the user, are they a user that's at a remote office? Are they in an office that I manage Wi-Fi and SD-WAN for them? Like there's so many different situations. And now it's kind of like the whole world has come into this person's responsibility, even though they don't control it necessarily. So they have responsibility to deliver great application performance. They may or may not own the app. They may or may not own much of the network that it's riding on, but they're still in that seat of responsibility. And the expectation is you can help me get the users of this business, performing well, understanding, getting insight, observability into these problems and correcting them. So they have that remit, and the tool needs to really find empathy for where they are today with how applications have evolved and help them understand internet performance, WAN performance is like you're calling it end to end, right? Like it's everywhere. It's the whole world now.
Yeah, absolutely. All right. Trend number 4 that we laid out in the agenda slide: AI-driven tools are streamlining and optimizing NetOps. At this point, I talk to network management vendors a lot. Probably have 2 to 5 conversations with a network management tool vendor every week.
Yeah.
At this point, I'd say 9 out of 10 of those conversations will touch on how they are applying AI to their products to enhance value. Either adding AI into, layering it into the existing tools in a variety of ways, like agentic, like a chat bot interface is pretty de rigueur at this point. Like I just talked to someone yesterday who's like, we've introduced a virtual network assistant to our environment. I'm like, congratulations, you're 4 or 5 years behind. No, it's not true, actually, maybe 1 or 2. But and others are doing like actual agentic operations at this point. Like,
Yeah.
but anyway, as that dynamic unfolds, I'm also aware of reduced skepticism among the buyers, the
Yeah.
users of these tools. When I was having conversations with people 4 to 6 years ago saying, hey, like, what do you think of the AI stuff that some of your vendors are starting to introduce? Like back then, like I'd be like, hey, what do you think of Juniper Mist, for instance? Because that one was kind of early to market. And some of them were like, I don't want that. It seems like I don't trust it. I don't see the value. I don't have compliance concerns. I don't want to. I don't want to automate things like that. Blah blah blah. Now, they are like gonna spontaneously tell me in conversations over the last year or 2 that this is something they're looking for even before I ask them. Um, and my research from this year says 92% of NetOps teams that I've surveyed believe it is important for network observability tools to offer AI-driven capabilities. And they see a lot of potential value from that. Like most of them say it's going to help us be more efficient from an operational perspective. It's going to allow us to fix things before they actually break in the form of proactive problem prevention. It's going to improve how I optimize my network. Like it's like, if I can do things around prioritization and traffic engineering based on things I'm seeing from AI, like, oh, let's address this queue here, whatever. And then secondarily, they are anticipating improved overall user experience, which makes a lot of sense given what the expectations around, fixing problems before they happen and optimizing the network. And then 44% of them say, I think this is actually going to drive cost optimization because, for instance, one example that I see from vendors is like, my network observability tool can actually identify that no traffic is going in and out of these instances in AWS. Why are they there? And then let's turn them off. That's just one example, but there are countless others. But Brandon, what's your perspective on this? Because I think
Yeah.
IBM is actually pretty well known for AI at this point. Thinking about Jeopardy and chess. But that's not what
IBM
you
loves to
did.
talk about AI, and I'm
Yeah,
sure you probably see headlines every week from
yeah,
IBM's talking about AI again, right? But we have clearly a lot to say about this. The first thing is like that market perspective that Shamus is bringing here aligns with folks that we talked to as well. A leader in one of the biggest credit card companies told me, I didn't expect this, right? I expected based on security, things leaving the secure enclave, et cetera, it might be one of the slower adopters. They said, no, it's not only a a desire of ours to have the agentic AI capability, it's a mandate. Our CIO has mandated this. Any new product we're selecting must have this capability. And being IBM, we have a approach to this that involves multiple pieces of solving this problem. The first one I want to point out is we recently announced something called IBM Network Intelligence, and you can either reach out or just find that on our website. And what that is doing, I think about it almost like a next generation of AI ops space and detecting um, root cause of incidents, but instead of being an aggregator of alerts and signals from multiple network monitoring, log monitoring systems into one, and then trying to kind of aggregate them. It's working directly with the signals, right? So if there's streaming telemetry from routers, if it's application performance data, anything can go into this kind of stream-based system and use a foundation model, not a language model, right? This model is specifically tuned for time series data and network data, and we use a foundation model to detect anomalies in real-time data from all sorts of infrastructure components, and then kind of summarize them, make them explainable. There is a chatbot interface, right, where you can ask further questions, but it could also be integrated downstream. So the second piece of IBM technology that I saw that I thought was really exciting and relevant here, we call concert workflows. You can drag and drop low code build automations that connect to, hey, we've detected an event using AI. I want to build a remediation using Ansible or Python or whatever. You can do that in the concert workflows product, but it also has the capability to build it for you using AI, right? So like you've seen a lot of AI code assistants. This is a low code product that's brought an AI workflow in where you can merely ask for, hey, I want something that changes, the QoS values on my Cisco iOS router, iOS XR. If you can just give it a pretty clear prompt, it can build a lot of those integrations for you, either from existing TypeScript code, Ansible code. Like it has a really rich model that it can reach into and generate most of those workflows for you, and you connect them to the detection side. You kind of have a closed loop that's all AI driven. The last thing I want to point out is from the SevOne product itself. How do I explore data that's maybe a little bit more complex? Maybe I've moved an application, it's partly running in the cloud, it's partly living in my data center. Maybe some of it's containers, but still some network appliances like F5 data power involved in that delivery. Identifying whether it's a network device, infrastructure, application problem. Um, Maybe AI doesn't know. Maybe I'm still investigating, right? Maybe I have a human operator who needs to get that analysis done quickly. We're building an agent similar to ones Shamus mentioned in other products, where you could ask those kind of network diagnostic questions and have those workflows done for you by the agent, and come back to you with a summary, right? So that's the piece that would be directly available within SevOne. And then a nice complement to that is the network intelligence and the concert workflows for whatever your mediations and your scripting needs are to close that loop.
Sorry, I muted myself while you're talking, and then I
Oh,
forgot to unmute
cool.
myself. Okay, last one. AI traffic drives new network observability requirements. I think I alluded to this at the top. Like I did some research earlier this year where I surveyed some IT decision makers around how they were preparing their networks for AI workloads and AI traffic. It looked at what they were doing to modernize the data center fabrics or build new data center fabrics. It looked at what they were doing to prepare their wide area networks, in terms of optimizing how traffic moves over them for AI, things like that.
Yeah.
But we also asked them how this is impacting their observability requirements. And so here's some just sort of like an overview of what I heard from them. One, it drives some rethinking of data collection. They said, I am seeing the possibility that I'm going to have to adopt some real-time infrastructure telemetry capabilities around, just getting more granular data off of my network devices, so that I don't miss events. For instance, and real-time traffic data, sampled flows are not good enough in certain parts of my network now. I need like a lot of flow data. They're also saying it's going to drive some new capabilities around analytics and reporting. For instance, we talked about AI aware network observability. That AI awareness needs to offer some depth around specific AI applications so they can recognize and provide intelligence around them, identify AI traffic that is not sanctioned so that you can deprioritize or block it if you see it, and give priority to whatever it is that is the sanctioned AI applications that you want to drive your business with. They want predictive congestion analysis, which gets into sort of the optimization stuff that we were talking about around AI-driven networking, and also proactive problem prevention. And they want AI traffic anomaly detection so they can, anomaly detection that is tuned to the specific thresholds that impact an AI application, for instance, because AI applications are, one, generating a lot more traffic than other applications that might have been on your network in the past, and they are very sensitive to adverse network conditions. So being able to look at anomalies from that framework will be important. And then just getting back to the previous slide, AI traffic intensifies interest in AI-driven network observability. People basically said that they saw that this transition to networking for AI was driving more interest in AI for networking. It's like a closed loop, Ouroboros type of thing. So those are some of the insights from the research. I don't know if that resonates with you at all, Brandon.
Well, it does, but I want to talk you through like an imaginary case study where a large insurance company is introducing an agent to their customers. And it really kind of builds on everything we've been talking about the compounding complexity of delivering multiple services to users with high expectations on performance over the internet, over the WAN, in the data center, in the cloud. That's all in play here now, right? And all of this kind of compounds in the performance of this agent is really sensitive to latency in a lot of ways. First, you imagine, let's say you've introduced an agent where on a mobile app, customers can ask about the status of a claim or ask about, their rates, right? They could ask questions that they may have asked a human agent in the past. That would have to access a lot of backend systems. And none of us are very patient, right? Like if we ask a question to an AI agent, we're not going to sit there for minutes for it to collect the information. We're like expecting it to respond to us in real time, the way a human responds to us. But the reality of what that agent might be doing to collect all the information required, it might be calling different MCP servers, right? Like that's the tool protocol to expose APIs to the language models. You might be partnering with something like Anthropic or ChatGPT, OpenAI to be that language model service, but you have internal servers, might run in your data center on mainframes, on Power, on Windows, right, that have some of the information in a database. You might have moved some of the applications components to Amazon, right? And it might be running on things like RDS, might be running on things like DynamoDB. All of those applications now have to coordinate back to an agent, back to an end user to answer their question. Imagine all the different round trips, the potential for latency packet loss to impact this. And if one of those things is down, they might just not be getting an answer at all. But it's not really clear, right? Like we're not building these experiences for users that give you insight into what happened there, right? Which is driving the need for better and better observability into all the facets of this thing, all the places that have to kind of collate data for the agent and ultimately the user. It does seem like it would make a lot of sense to have AI capability to kind of debug that stuff and identify what's the most likely cause of a lot of latency, a lot of complexity in the system, but what's the root cause of why users aren't getting answers or why answers are coming slowly and potentially users are abandoning and leaving my app, right?
Right. Okay. So that just to wrap up in review, some of the things that might be causing your network observability tool set to be aging faster than you thought. Application awareness, it's empowering NetOps to manage services rather than infrastructure. If your tool sets are still sort of oriented from bottom up, from network up to apps, as opposed to from the app down the networks, you might be vulnerable to gaps in your ability to deliver a good application experience to your customers, your users, your employees. Cloud-based management drives cost optimization, resilience, easy use, and more. It is going to cause some turbulence in your third-party network observability tools and their ability to, one, get visibility into cloud-based management, just in the way those vendors are architecting your tools. But also it is a new consumption model for your tools in general, including network observability tools that can impact you in a lot of positive ways. End-to-end visibility across on-prem, SD-WAN, cloud, and more is essential because all those new domains on your network are adding complexity and creating visibility gaps, especially if you're relying on the observability capabilities native to those siloed domains and not stitching them together into an end-to-end view. AI-powered features from your tool vendors are going to amplify the power of your tools. And AI traffic and AI workloads on your network are going to drive changes in your tool sets from a data perspective, from a dashboarding, reporting, and analytics perspective, and it's probably going to intensify your interest in consuming AI-powered network management capability. And with that, I think Brandon and I are open to taking questions from the audience. I'll let Raleigh come back on. Thank you, Raleigh, for being here. If you want to moderate the Q&A for us.
Thanks, Shamus. Before I jump into the Q&A, I wanted to direct everyone to learn more about IBM SevOne. You can use these QR codes to request a demo and join their community. Brandon, starting with you, with AI-driven observability now becoming mainstream, how does IBM SevOne differentiate from other tools that claim to provide AI insights?
Sure. Well, I've looked at a lot of other people's, I've looked at a lot of other companies building tools like ours or tools that are in a similar space, the observability space. And I've seen kind of different levels of the depth of what I would call reasoning, right? And we really are attempting to build a solution in SevOne that does a lot of the reasoning for you. It's not just um, it doesn't just go fetch things for you. It's not just a language model way or a natural language way to use the product. It's an agent that is really going to help you a lot in your analysis and shortcut a lot of the work that it would have taken to get to results. We want to be able to ask a really articulate question, something like, what different factors might be affecting Zoom application performance in my Chicago branch? And with insight into SD-WAN and Wi-Fi and maybe cloud connectivity there, all the things that may be in play, doing a lot of that analysis for you instead of just, some tools can regurgitate things and some tools can deeply reason about them.
Thanks, Brendan. Jumping over to you, Shamus. In your research, what are the biggest adoption barriers enterprise face when moving from a legacy monitoring to cloud-based observability platform?
The biggest one is security and compliance, data privacy. I still talk to network engineers who tell me my data is never going to go to the cloud. I don't want my data going to the cloud. I don't care what data is going to the cloud. None of it can go. I think most SaaS vendors try to anonymize, summarize, and secure that data as much as it is possible. But there's certain industries that aren't comfortable with it, certain corporate cultures that aren't comfortable with it, like aerospace and defense, for instance. Generally, my conversations with them, they're still pretty adamant about not doing it. Financial services, I've seen some shift there. From conversation to conversation, certain banks or insurance companies will now say, yeah, we're open to it. So that's probably the biggest one. And sort of related to that is data sovereignty. Certain geographies are like they don't have a lot of options here. If they have a data sovereignty thing that forces them to, reject an offer of moving to the cloud because the vendor that they're working with doesn't have a specific solution for their sovereignty requirements in their geography. And then one other one that can come up, I mean, there's several, but one other one that can come up is cost. Although that one I think is less tied specifically to SaaS at this point, like cost from the perspective of shifting from perpetual licenses on the tools that you traditionally deployed on premises to a subscription license of some kind for the SaaS tool. There's some math involved that may cause you to perceive the long-term costs of a subscription-based offering to be more expensive overall, like the cost of ownership to be higher. But that depends on like your historic approach to how long you stay with a tool that you bought with perpetual license for and how much the support costs of it are over the term of the term of using it. And also one thing that makes this less relevant is that many vendors are that offer an on-prem tool are shifting to subscription-based models anyway. Like they will sell you a subscription for an on-prem deployment. They might, obviously they're not going to, well, depending on the vendor, they're not like killing perpetual licensing completely in many cases because they don't want to upset their vendors, I mean their customers, but that are married to it. But yeah, they are encouraging people to shift to a subscription-based model because they're trying to move to an annual recurring revenue stream. I mean, not just in the monitoring tool space, but your switching vendors and routing vendors are doing this too. So that's just the fact of life at this point.
Thanks, Shamus. Jumping back over to you, Brandon. How is IBM helping customers manage visibility across multi-cloud environments, especially when data lives in AWS, Azure, and GCP simultaneously?
It does. I mean, it's so difficult, right? But we have done some really innovative stuff on how to manage all three of those clouds. And it's kind of similar to the conversation we were having a few minutes ago about the different controllers. Like you don't want to go different places to understand an application that might have components in Azure, might have components in GCP, and those tools aren't consistent, and they aren't always the most powerful observability tools, the built-in ones, right? Like they're a cloud provider, not an observability player. So we've worked with all the product teams at the three clouds to figure out the best way to bring in the most data and in a way that's kind of cost efficient, right? Because as Shamus was talking a little bit about the move from you know, uh, on-premise to SaaS, a different cost model, right? Amazon kind of pioneered this. We meter you for every second of usage, right? Every time you call their CloudWatch API or Azure's metrics APIs, you're getting charged something. And we found some really interesting ways to extract that data in bulk, so you're not paying a huge bill for just the sake of getting your own data out. And we try to be cost efficient there, but also normalize it and put it into one tool so that you can see it all in one place and understand it holistically end to end. As this is my application, yes. As a major financial service or a major telecom, I might have agreements with all the clouds that I have to consider, right?
Thanks, Brandon. And how does IBM's approach to network observability leverage both AI and domain expertise, ensuring trustworthy insights rather than black box automation?
Well, people on my immediate team, people like Rupert, people like Matt Sweet we have over 100 years of network experience building real data centers and working in the financial service and the telecom world. So when we talk about building agents, it's not an abstract concept. We're really bringing, hey, there's workflows that I did every day that I want to automate, and I want to be able to have this, either fully automated experience or this natural language experience with that level of network domain expertise, for lack of a better term. And we're baking stuff like that in. So that's a big piece of where we think we might be different from people who are more not network specialists, right?
Great. Thank you, Brandon. To wrap up, I'll throw out this question. You can both provide your insights. It's as AI traffic continues to surge, what practical steps should enterprises take today to prepare their networks for AI-driven workloads and telemetry?
Okay, well, I mean, one thing that's probably top of mind is like if you're going to have a lot of AI workloads in your data center, if you're building out GPU clusters, you're probably thinking about modernizing your networking fabric, maybe building a new one, using new protocols or an emerging ones like RDMA over Ethernet and various other ones. So, that's one thing you're probably already thinking about. On the wide area, you're going to have AI traffic on your wide area. You might be moving a lot of data around. You might be trying to move your models to the edge to access data that's living at the edge that needs to be close to business critical systems to make decisions, for instance. So that means you probably want to look at your WAN optimization, your software-defined WAN, SASE capabilities to see if your vendors there are making their traffic optimization, their traffic routing, their deduplication tools, whatever, fluent in AI traffic and AI protocols so that they are capable of accelerating and optimizing how AI application traffic traverses your wide area. And then we kind of touched on it from an observability perspective. I think one practical step to take is to talk to your vendors about streaming, real-time streaming telemetry. It's not widely available because there isn't really a universally acknowledged, embraced standard for that. And so you see a lot of variation in availability and support of such a capability from the network infrastructure vendors that you work with, and also the network observability tools that you use for a variety of reasons. One, like up until now, they still haven't seen a lot of demand from it for customers, but I think that demand is going to emerge. And two, the lack of standards makes it hard for them to provide wide support of it. So I think you should start talking about your vendors and being like, where is the standard here? Why haven't you done it? They're going to probably tell you it's because it's kind of niche, and they've just been supporting whatever their customers ask of them, especially in the hyperscaler world. But I think that's going to change in the near future.
All right, great. I like the setup because there's no standard. Things are getting into multiple clouds and things are getting more complex. But I go back to my days in operating some of these large networks, and there kind of is a standard underneath all of it. And two things that emerge in my mind right now as how we think about these technologies. We have containers. We used to have VMs. Now we have containers as kind of a unit of application. And then we have the packet, right? So you think about the OSI model. You really can't lie when you have a packet capture. And I was recently talking to uh, a woman who's an SVP at one of our biggest banks in North America. And she's like, our team is going down to the packet level all the time. How can we bring that up a little bit? And the technology that I want to highlight here, people thinking about, I'd love to have you reach out if you have this problem. It's called eBPF. It's a capability within the Linux kernel to deploy these lightweight instruments or sensors. And we've partnered with Red Hat within IBM to create something that can extract information right out of the container runtime about network performance and analyze it in SevOne. So we think as you're building on these different clouds, we think the kind of common denominator there is your containers and the Linux kernel. And eBPF is a really exciting way to extract data there without going to the level of expensive sniffers and probes and things. And it's low overhead and it's awesome. So I want you to consider that.
Great. Thanks for sharing that information, Brandon. And thank you, Shamus and Brandon, for taking those questions. I will be sending out a follow-up email that will include resources from today's event, so be sure to check that email out. Thank you for joining us and enjoy the rest of your day.